Hi, my name is Maria. I'm a solutions architect based in Sydney. At AWS, security is job zero. And I'm really proud to work for a company that has always taken security as their top priority and always will. What do I mean by job zero? It's there implied at the start of every single thing we do at AWS. Before we get to number one, we always think about security. Today's talk has a very simple structure. It's broken in three parts. Common questions about security of the cloud itself, questions related to security of a particular AWS service, and questions focused on data security and privacy. I'm using some light-hearted terms today. You'll hear me talk about myths that are dispelled and myths that are busted. But we understand these are serious topics. Let's get started. The first thing that I want to talk about is the misconception that some customers have in early stages that maybe their physical on-premises infrastructure is more secure than the public cloud. A good place to start is by looking at the physical security. The same security isolations are employed as would be found in a traditional data center. Physical data center security, separation of the network, isolation of the server hardware, and isolation of storage. We undergo third-party audits to confirm the security and compliance controls we say we have are actually implemented. As a result, the most highly regulated organizations in the world trust AWS every day. In addition to the standard physical security controls, using AWS gives you unprecedented visibility into your environment, your resources, and its changes. For example, in a traditional model, routine maintenance on a router is often not logged. In AWS, using AWS CloudTrail, which is our primary logging mechanism, all that activity would be logged. You would know who made what change, from where, and when. Finally, almost all services and features in AWS are available via API calls. This level of automation, combined with the visibility, allows security teams to perform near real-time detection and remediation of attacks or misconfigurations. You can operate an environment that self-heals when misconfigurations are detected. When customers move to the cloud, there is often misconception about data access and data ownership. So I would like to dive deeper into this. AWS has got a really simple and straightforward principle around it. AWS customers are always in control and always maintain ownership of their own content. AWS will never access your content without your explicit permission. For example, we will never use information that you share with us or content in our system for advertising or for any other marketing purposes. And because you control ownership and you control access to your data, when you pick a region to store your content, that content is not going to leave that region. We provide a series of very strong access controls, primarily through our Identity and Access Management Service, or IAM, and this allows you to create users, groups, roles, and assign them permissions. IAM is exceptionally important because identity is a key principle in cloud security. And why is this? Well, the access model is very different. Traditionally, you used to build servers and install applications on them and then grant somebody else access. In AWS Cloud, it's the opposite. We are giving you access to environment through which you're using a set of applications to be creating virtual infrastructure. This means that who you give access to and how you control this access is critically important. CloudTrail, which I mentioned before, is enabled by default across all services and all accounts, including yours, for 7 days. If you'd like to keep it longer, all you need to do is to configure it to be saved to an S3 bucket. This combination of strong principles around data ownership and you own your content, strict access controls through identity and access management platform, and the visibility you've got through CloudTrail is a really good way to understand where your content is. Let's have a look at the next myth. Some customers have a misconception that because they're highly regulated, they can't use the public cloud. It is important to remember we have millions of active monthly customers in some of the most highly regulated industries in the world, including healthcare, finance, and public sector. We help customers achieve their own compliance requirements by leveraging our global security assurance programs. Examples include ISO 27701, 17, 18, SOC 1 and 2, PCI DSS, and many, many others. When customers move to AWS, they inherit these compliance controls, allowing them to focus on the security model that makes sense to their business. In addition to global compliance certification, we also invest in regional certifications to allow customers to meet country-specific requirements. For example, here in Australia, we have been on Australian Signal Directorate, or ASD's Certified Cloud Services list for a few years. We recently released our updated IREP document to help customers evaluate workloads they run at the protected level, with 46 AWS services in scope. AWS's global compliance program has other information as well, such as our mapping of upright risk guidelines to AWS's below-the-line compliance controls. Both of these documents help our government and financially regulated customers in Australia run their workloads on AWS. Finally, customers also have the option to enroll in an enterprise agreement with AWS. This gives them the option to tailor agreements that best suit their needs. If you have a specific regulatory requirement, please contact your AWS representative. Some customers have misconception around sensitive personal data and what they can and can't do in the cloud. Encryption is the fundamental control that enables you to store and process sensitive data in the cloud. And I love talking about it with our customers. One of the best things about encryption services is they are so broadly available. They're built into other 35 services and very often just a single click away. For example, I mentioned Amazon S3 before, our popular simple storage service. And we also have Amazon EBS, Elastic Block Store, which is another storage type. Both of these services allow you to encrypt data stored at rest with a single click. AWS Key Management Service, or KMS, presents a single view into all of the key usage in your organization. You can easily create, import, and rotate keys, as well as define usage policies and audit that usage. We've got another very popular encryption service called Cloud HSM, that is Cloud Hardware Security Module. It is often used in more advanced use cases and applications that are needing a different type of cryptography. KMS is validated at FIPS 140 level 2 and Cloud HSM at level 3 globally, which is one of the US government's strictest cryptography standards. It means that our regulated customers around the world can leverage these cryptographic services. Some of our customers have requirement for security testing, which is awesome, by the way, but they feel like they're not allowed to do that in the cloud. When we talk about security testing, it's really important to understand the concept of AWS shared responsibility model. Let me explain that. As the service provider, AWS is responsible for what we call security of the cloud. It means we perform security tests of the infrastructure that we use to provide our services. You, as a customer, are responsible for things you do in the cloud, or what we call security in the cloud. As per our acceptable usage policy, we require customers to seek approval to perform a penetration test. It's a very straightforward questionnaire that you can complete in AWS console. Now, what if you operate DevSecOps environment and seeking approval manually is not feasible? You have an option of using pre-approved Amazon Machine Images, or AMIs, provided by third parties on AWS Marketplace. I should also mention Amazon Inspector. It's a host-based agent that you can install on your EC2 instances that allows you to perform vulnerability scans at any point in time. It detects publicly known vulnerabilities or security deviations from the best practices and rates these findings. It means your security team can review the findings and focus their time where it matters the most. So I've just covered 5 of the most common general security questions. I'm now going to dive into some service-specific questions. So we've just talked about security testing and identifying vulnerabilities. Let's talk a little bit about patching your resources. And whose responsibility is it? I must say, responsibility around patching is sometimes a source of confusion for our customers. It comes down to our shared responsibility model that I've just mentioned. If you choose to launch EC2 instance and install MySQL on it, you have administrative access, and it means that it is your responsibility to keep both operating system and MySQL patched. We recommend that you use the vendor's built-in automatic update tools. I should also mention the AWS Systems Manager, which is an automatic and remote way to do different administrative tasks, including applying patches. And this is a really good way to dynamically keep the environments that you're managing up to date over time. If your environment is not long-lasting and you choose to rebuild it dynamically, then we encourage you to start from a known good patch base. We provide Amazon Machine Images, AMIs, of many popular operating systems, and we keep them up to date. Now, there is a different set of services at AWS that we call managed services. It means we take much more responsibility around the fundamental security of those. Amazon S3, Simple Storage Service, Amazon RDS, Relational Database Service, and AWS Lambda, which is our code execution platform, are great examples of a managed service. If you choose to run managed MySQL using Amazon RDS, instead of installing MySQL on EC2, then it is now AWS's responsibility to keep underlying operating system and MySQL up to date. Let's have a look at another myth. Some customers concerned that when they put data in the public cloud, that everybody can access that data. And this is another great extension of the shared responsibility model, which we talked about already. Let me give you an example. Amazon S3, like all AWS services, implements secure by default settings where possible. When a user creates a new S3 bucket, by default, that bucket is entirely private to the person that created it. You can use IAM to prevent users from ever creating public buckets in the first place. If a user creates a public bucket or changes private bucket to be public, a big, bold, orange message appears saying, "This bucket will have public read access. Everyone in the world will have read access to this bucket." And this is the first step in a series of notifications that alert the customer to the presence of public buckets. As AWS services and features are accessible via API calls, your security team can auto-remediate in near real time. For example, if I create a public bucket, this event can trigger a Lambda function to review the permissions, remove public access, and alert the security team. This level of automation is not possible in traditional models. If you were to compare it to FTP, it is highly likely that FTP server with sensitive content would go undetected for long periods of time, maybe until the annual penetration test. We just talked about data loss prevention. Some customers have concerns around their access keys being stolen or lost. What can we do about it? We've got some really straightforward best practices on how to protect that most important security principle that I mentioned before, identity. The first and most straightforward way to do this is to always use multi-factor authentication, or MFA. Either a soft token on your phone or a physical device that will give you a temporary, time-bound, short numeric PIN. I think many of us are familiar with the process. You can also pick high-risk API calls and apply MFA protection to them. Now, this myth talked about access keys being stolen. The best way to keep this from happening is to not allow any access keys to be created in the first place. Instead, use an IAM role. An IAM role is an AWS identity with permission policies that determine what the identity can and cannot do in AWS. Instead of being uniquely associated with one person, a role is intended to be assumable by anyone who is authorized to use it. And best of all, a role does not have long-term credentials. Temporary security credentials are dynamically created and provided to the user. Using MFA and IAM roles are the two of our recommended best practices for protecting identity. So they cover protect, but what about detect? There are multiple ways to detect inappropriate IAM access, but the one I want to highlight is Amazon GuardDuty. GuardDuty is a managed threat detection service that continuously monitors for malicious or unauthorized behavior. It monitors for activity such as unusual API calls or potentially unauthorized deployments that indicate a possible account compromise or potentially compromised instances. If GuardDuty notices suspicious or dangerous activity, such as login attempts from the same account from multiple places in the world, it will send you an alert and you can take the appropriate action. It's got no operational impact when you enable the service. GuardDuty has a 30-day free trial and is popular with our security-conscious customers here in Australia. I highly recommend you turn it on today. All right, let's talk about deleting content. Is it actually deleted? How could you verify that? When we talk about the deletion of customer content in AWS, we need to think about it in both physical and logical terms. From a logical perspective, when a user makes a delete call, depending on the service, we will either remove the data identifier to make the data inaccessible, or we zero the data by performing an overwrite to render the data unreadable. When a physical storage device has reached the end of life, AWS procedures include a decommissioning process that is designed to prevent customer data from being exposed to unauthorized individuals. AWS uses techniques detailed in NIST 800-88 as part of the decommissioning process. Production media is not removed from AWS control until it has been securely decommissioned. I previously mentioned that we have global compliance and security assurance programs that document and independently test the controls that we say we have. Physical and logical deletions are great examples of that, and you can refer to these reports in AWS Console using AWS Artifact. Let's change gears and talk about security in serverless context. Serverless services are here to stay. We see customers in Australia using serverless applications to process sensitive data in production. A great example is AWS Lambda, which is our code execution platform that lets you run your code without requiring you to provision or manage servers. But how do we do it? How do we secure it? The shift towards serverless is a shift towards using identity as the primary mechanism of security. I already talked about granularity and control that our IAM tools provide. All of this control is really useful when you're configuring who can access your serverless components and what they're allowed to do, and which other services they can interact with. Lambda is built on top of EC2 and inherits the strong isolation inside of EC2. The code you choose to run inside of Lambda is executed inside of a container that we manage, but that is allocated to you. And that container runs in an EC2 instance that we manage that is associated with your account. Code from different AWS accounts always runs on a different EC2 instances. Every single request to Lambda is independently authenticated and authorized by AWS. And every single request to Lambda can be audited and programmatically analyzed. Using our serverless services means AWS takes much more responsibility for the security of that service. AWS provides and secures the operating system, the container, the application, and language runtime environment on your behalf, which means we harden everything and keep it patched. Our customers find that never having to worry about applying another patch inside of that serverless environment is a big relief. We also take care of isolating that environment at the network layer, and we provide access to logs from serverless and other services via AWS CloudTrail. All you need to focus on is the security of the code that you want to run and who you choose to grant access to that function. All right, so that was 5 general cloud security myths and 5 service-specific ones. Now we're down to the last 3, focused on data security and data privacy. This myth here is that the government can access customers' content anytime. We are vigilant about our customers' privacy. We do not disclose customer content unless we are required to do so to comply with the law or a valid and binding order of a governmental or regulatory body. They need to follow the applicable legal process to get those, and we review all orders and object to overbroad or otherwise inappropriate ones. Unless prohibited from doing so, or there is a clear indication of illegal conduct, we notify customers before disclosing customer content so they can seek protection from disclosure. It's also important to point out that our customers can encrypt their content, and we provide customers with the option to manage their own encryption keys or architect applications to implement on-premises encryption. Access to encrypted data is meaningless if you don't have access to the relevant decryption key. But what about malicious insider getting access to customer content? This question often comes up in a context of managed services. One of AWS's most important internal security principles is keep humans away from data. The more opportunity a human has to directly touch systems or data, the more of a chance a mistake will be made. Instead, our services are built upon layers of automation. And the way we update these services is by creating automation to update the automation. We cannot operate at hyper scale if our services rely on human intervention to function. However, there are exceptional circumstances when a human administrator will need to manually access a service to fix something. AWS uses layers of technology controls and process controls to provide protection and oversight. For example, no one with physical access to the data centers has logical access to manage our services, and the other way around. Process controls examples include employee background checks, explicit requests for elevated level access, and these requests are tied to service tickets, all actions logged and reviewed by service teams. These layers of technology and process controls are described in our global compliance reports that you can access in AWS Artifact. All right, the last myth. This is something that we talk about with technology-savvy customers who are concerned that the isolation technology could be bypassed and that one customer might be able to get access to another customer's content. As we like saying at AWS, there is no compression algorithm for experience. AWS has over a decade of experience of building, managing, and securing multi-tenant cloud infrastructure. Our core technology is a combination of hardware and virtualization software. Today, we run 2 hypervisors that virtualize and isolate host CPU and memory resources. One based on the open source Xen hypervisor and our new Nitro hypervisor based on the core KVM code included in the Linux kernel. We are founding members of the Xen project, and in addition to a deep understanding of how Xen operates, AWS is notified in advance of security issues that are discovered within Xen. That allows us to determine if an issue could impact AWS or our customers, and, if so, deploy a fix non-disruptively. Many of the issues that are discovered in Xen do not impact AWS because we use a customized version of Xen from which we have removed many unnecessary features, often replacing software components with our own hardware components. This is why most of our public security bulletins related to Xen simply say, AWS customers are not affected by this issue. Over the past 4 years, we have been implementing our Nitro system. C5 and M5 instances are great examples of that, which moves all networking and storage processing out of the software into our own hardware. This improves both the performance of your applications and also increases the isolation between the management functions and the operating systems you manage. AWS's compute, network, storage, and other services offer you isolated environments so you can be sure that your data cannot be accessed by anyone else. AWS uses multiple layers of physical and logical isolation inside of our services to ensure they are secure and your data remains private. And like all other important controls, we provide evidence it's working properly via independent audits and our global compliance programs that you can find in, yes, AWS Artifact. An example of how successful this approach is was our response to the Meltdown vulnerabilities earlier this year. In early January, security researchers disclosed the Meltdown and Spectre vulnerabilities a week ahead of the planned date. AWS was already nearly complete with deploying mitigations for these new vulnerabilities. Within 24 hours of the early disclosure, the remaining small single-digit percentage of instances were protected. That covers 13 most common security myths that we come across. To close off, I would like to highlight the most important security benefits of AWS Cloud. We touched on many through the course of this talk, but I thought I brought them together here so you can see our latest thoughts on the topic. Our millions of active customers all around the world benefit from the security and compliance controls that we engineer to meet the standards of our most security-conscious customers. We allow you and your security teams to scale the speed of control and the breadth of visibility to match the pace that your development teams are working at. We meet the strictest requirements for privacy and data security around the world, especially here in Australia. Our services are built on automation and are meant to be used to automatically secure the applications you build in the cloud. And finally, we didn't touch on it today, but there is a very large number of security technology partners and security consulting partners. So after this talk, please go check them out on AWS Marketplace and AWS Partner Network website. So what's next? I hope you now have a better understanding of how AWS works to keep the cloud secure. Your call to action is to go out and help us spread the word. We have a new website to help you do that. It answers a simple question: what makes the cloud secure? It's meant for chief executives who are considering a move to the cloud. And finally, we like this quote a lot and wanted to share it with everyone here. The most important thing to remember about cloud security at AWS is it's a shared responsibility. We take our responsibility for security in the cloud very seriously. It's our top priority at AWS and always will be. It's your responsibility to choose which services you want to use and to make good decisions about how to configure them. Your decisions about how to configure our services, who to give access to, how to turn encryption on, when to connect your applications to the internet are the most important security decisions you can make in the cloud. We encourage you to learn and read our public documentation and be curious and ask us questions about what AWS does to secure the cloud. We need all of you to take the time to understand the security benefits of using the cloud and then learn how to get it right. We are all in this together. Thanks for working with us to keep the cloud secure. Thanks for your time today, and I encourage you to continue posting your questions on the console. And in the meantime, we'd love to keep getting your feedback. Please take the time to complete the 3-question poll.